So this is a uniform motion problem. Says a plane flew 360 miles in 2 hours with the wind. It took 3 hours to travel the same distance against the wind. What is the rate of the plane in still air and the rate of the wind? So before we can do anything, we have to assign variables to what we're looking for. So it says, what is the rate of the plane in still air and the rate of the wind? So that's what we're looking for. So let x equal, and we'll say that's the rate of the plane in still air, and then we'll let y equal the rate of the wind. Alright, so we have our variables, and with a uniform motion problem like this, we're always going to use the formula distance equals rate times time. Now let's think of our two situations first. We've got two situations. We've got the plane flying with the wind, and then we've also got the plane flying against the wind. Alright, so in the with the wind situation, we've got the plane flying. So this is our plane. And then the wind is going in the same direction, so it's pushing us or helping us. So if the rate of the plane is x and the rate of the wind is y, then we need to add because the wind is actually helping us or giving us additional speed. So here our rate, or r, will equal x plus y. And we know the time with the wind says 2 hours with the wind. So t is going to be 2 hours. The distance, d, is 360 miles. So 360 miles. So when we have distance equals rate times time, the distance is 360, the rate is x plus y, and the time is 2. So if we distribute, we get 360 equals 2x plus 2y, and then all we need to do to get this in standard form is reverse the equation. So we've got 2x plus 2y equals 360. So there's our first equation with the wind. Against the wind, if our plane is still going in the same direction, so this is our plane, but the wind is working against us now. It's going in the opposite direction. So in this case, the wind is actually pushing against us or hurting our speed. So our rate will actually be the rate of the plane minus the rate of the wind. Now the time says it took 3 hours to travel the same distance against the wind. So the time is 3 hours, but the distance is the same, 360 miles. So when we go to use our formula, distance equals rate times time, distance is still 360. Our rate, since we're going against the wind, is x minus y, and our time is 3 hours. So then we distribute, and we get 360 equals 3x minus 3y. Flipping this equation around as well, we get 3x minus 3y equals 360. So now we've got two equations, equation 1 and equation 2. They're both in standard form, so we'll probably want to use the addition method. So that's going to be 2x plus 2y equals 360, and 3x minus 3y equals 360. Now, anytime I have a subtraction, I change it to addition of the opposite sign. So minus 3y becomes plus negative 3y. So remember, when using the addition method, we want opposite coefficients on either our x variable or our y variable. If we look at our y variables, we've got 2y and negative 3y. So they already have opposite signs. So let's eliminate y. So we'll multiply our two equations. Now, to get the same number with the opposite sign, all I have to do is look at the equations. So for the first equation, I look at the second equation and see that it's a negative 3. So if I multiply the first equation by 3, then when I distribute, I'll get 3 times 2, which is 6y. And if I multiply the second equation by 2, then when I distribute, I'm going to get 2 times negative 3 is negative 6. So I'll have 6y and negative 6y, and those are opposite coefficients. So distributing on the first equation, I get 6x plus 6y equals, and then 360 times 3 gives me 1080. Distributing on the second equation, I get 6x plus negative 6y, so the 6y and the negative 6y are opposites, equals 360 times 2 gives me 720. Now I want to add these together, so 6x plus 6y is 12x, or 6x plus 6x is 12x. 6y plus negative 6y is 0y, so that cancels. And then I get 1080 plus 720 is 1800. Now to get the x by itself, I need to divide by 12. 12 divided by 12 is 1, so that cancels. And I have just one x left, so x equals 1800 divided by 12 is 150. Now x, if we go back to our let statements, x equals the rate of the plane in still air. And since we traveled 360 miles in 2 hours, our rate is in miles per hour. So that's miles per hour. And we'll say this is the rate of the plane in still air. Now to get the speed of the wind, or the rate of the wind, I just have to go and grab one of my equations. So let's just use the first one. We'll use 2x plus 2y equals 360. But now I know that x is equal to 150. So I substitute that in for x. So 2 times x, which is 150, plus 2y equals 360. 2 times 150 is 300. Y equals 360. To get the y by itself, I can first subtract 300. That's going to cancel here, giving me 2y equals 360 minus 300 is 60. Now to get the y by itself, I just divide by 2. And that's going to give me y equals 60 divided by 2 is 30. Once again, this is in miles per hour, so it's miles per hour. And this is the rate of the wind. So we'll say rate of the wind. And we're done.